Okay, technically get difficult as I hit the wrong button on this thing. It's hard to film this. So where was I? I was saying this is the S waves here. This is where the focus of the earthquake is. You see this huge S wave shadow zone. The whole other side of the earth does not receive S waves. Now we try to put this down so that it doesn't roll everywhere and get back to where we were. So what we're going to see here is, what am I doing? So that what I just showed on that diagram, that's what all this blue is supposed to represent. It is difficult to know it on the flat sort of piece of paper, so that's why I like having those globes right there. That's the S-wave shadow zone. That's the point of this. This is how we know about inside Earth, is where these S and P waves travel to. Okay, so 7, lightly color the outer core red and the inner core blue. Outer core red, inner core blue. So outer core is this, okay, outer core, and you could probably look it up on the reference table, page 10, but you probably could kind of figure this out. Most people, I think, just kind of know it, or at least maybe start with the inner core, is that section in the middle. So I'm doing outer core red. I'm doing outer core red, here we go. Inner core blue. So, there we go. Inner core solid, outer core is liquid. Again, the way we know the outer core is liquid, because we know something about S waves and what they go through and what they don't go through. They don't go through liquid. We can figure out that they have this big shadow zone, so therefore the outer core must be some sort of liquid. Liquid rock, don't think water, nothing like water, very different. So, alright, let's answer some questions, shall we? Refraction is when waves are bent. Waves are refracted at the interface or boundary between materials that have different densities. That's the key. Different densities will cause refraction. Example, white light is refracted by the glass of a prism, if you've ever seen that. This bends the white light waves and causes it to separate into the colors of the spectrum. This happens because the waves of each color light is refracted differently, and that's the Roy G. Biv, the colors of the rainbow. We will be learning about that in about 2 or 3 weeks, if you've never seen that before. So, let's just go through some of the answers here. Talk about refracting. This is just really sort of getting you through how many times it gets refracted. We kind of did some of that. Which location will record the greatest difference in arrival times between P and S waves? A, B, C, or D? If the focus is here, D is going to have the bigger difference because they're further apart. P waves travel faster, S waves travel slower. You have to know that about the S waves. It's not going to be obvious from this diagram, but I think a lot of people know that already. According to the diagram, at which layer of inner Earth do S waves stop traveling? And that here, as I've said before, that is the outer core. Outer core. That is key. Outer core. Scientists know that S waves cannot travel through liquid rock. Since S waves do not travel through the outer core, therefore we infer that it must be liquid. Do P waves travel through the outer core? And the ones we see here, they all hit it. None of the P, this one just grazes it, but this goes through, goes through, goes through, goes through. P waves do go through the outer core. That answer is yes. 6. What type of earthquake waves will a seismic station at location D receive? So what we're trying to get at here is it's in the zone of all the P waves and all the S waves, so it receives both. Don't be caught up on what's pointing directly towards it. So the answer is both P and S waves. What type of earthquake waves will seismic station located at E receive? E. Now, E is in both the yellow of the P wave shadow zone and the blue of the S wave shadow zone. So, the answer is neither. Neither. They receive no record of that earthquake, if that's where they're located. What type of earthquake waves will a seismic station at F receive? F is here, and the answer to that should be just P waves. No S waves, just P waves. There's a large number of P waves that come here. We only see a few, just the way we had to draw it. So, P waves only. And then which location will receive S waves? Of those, S waves. Of those, the only one that would be H in this case. H. So, some of this is just kind of helping you understand it, but hopefully, I really like these things here that we did. Again, the S wave shadow zone here. Okay, so that is sheet 190, right, for all of us here at GazdaHW Productions. Thank you for watching.